to talk to you today about 4.1. We started this in class on Monday, and since I know you guys miss geometry so much when you don't get to do it, we're going to continue on with section 4.1. So if you remember, chapter 4 is all about triangles. So we talked about all the different types of triangles and how we were going to classify them. And at the end of class on Monday, we talked about a couple of theorems. So the first thing I want to start off doing is making sure that we have all of your information filled in for your theorems. So just a quick review here. We have, this is probably the most important theorem when it comes to triangles. Remember, you were going to quiz your parents for me, right? You're going to give your parents, your dad's pop quizzes, and ask them the interior angles of a triangle. So the inside angles, which are the ones that are inside here, right? Every single triangle, if you add up all three interior angles, always, that adds up to 180 degrees. So every triangle, if you add up the three interior angles, the sum of the measures of the interior angles of a triangle is 180 degrees. So I'll let you guys pause this and ask your parents if they remember that. Sum of the interior angles of a triangle always equals 180 degrees. And then we have this corollary theorem down here that goes along with it. So the corollary theorem says, all right, we know that every triangle, all three angles add up to 180 degrees. What happens if we have a special kind of triangle, which is our right triangle? And when we have a right triangle, we know that this right triangle has one of the measures is 90 degrees. Well, if I know that all three of the angles have to add up to 180 degrees, that means my remaining two, so let's call this one angle 1 and this angle 2, that, or actually I'll use what the diagram says, A and B. We know that if everything adds up to 180 degrees, right, and one of my sides is right, so I know that's 90 degrees, that means that I have 90 degrees left over for A and B, the measure of angle A and B, okay? And since we spent a lot of time in geometry learning all kinds of fancy words, we know that if you add up A and B together and they equal 90 degrees, we have a special name for that, and that is that A and B are complementary. Complementary. Oh, I'm running off the page. Complementary. So that's your fill in here. The acute angles of a right triangle are complementary. So the measure of angle A plus the measure of angle B equals 90 degrees. And that makes sense, right? And the reason this is called a corollary, remember, a corollary is something that you can easily prove based off of another theorem. So based off the fact that we know all triangles, interior angles add up to 180 degrees, and if we have a right triangle where one of them is 90 degrees, that means the other two have to add up to equal 90 degrees as well. All right, so that is our theorem 4.1 and theorem 4.2. Now we also have theorem 4.2, which is the exterior angle theorem. So now we're talking about the angle that is outside the triangle. So let me draw this a little bit bigger here. All right, so we have angles A, B, and C. Okay, and this kind of refers to our interior angles. And then we have an angle out here that we are calling angle 1. So this is the one that when we kind of look at it first, it's like, really, is that true? But it is true, okay? So the measure of angle 1 is equal to the measure of angle A plus the measure of angle B. And the fill in here is, I'm not going to be able to fit in there, non-adjacent. That means the ones that are not next to it, non-adjacent interior angles. Okay? So let me just read this theorem out. The measure of an exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. Okay, so what this is basically saying is that if you want to find out what 1 is, the measure of angle 1, you have to add up the measure of A plus the measure of B. And that will give you the measure of angle 1. It's written out here, right? Really neatly for you, right? And we did a quick proof of this in class, but I think it's worth doing again really quickly. So here we go. We know, we just learned this most important one, right? That all of my interior angles add up to 90 degrees. So if I switch to a different color here. Okay, so if I add up the measure of angle A plus the measure of angle B plus the measure of angle C, and I expand my page so I have a little more room. Oh, yikes. Let's undo that. There we go. All right, so I add those up together. By my first theorem, by that thing that always is true about triangles, we know that the interior angles add up to 180 degrees. Okay, now let's switch colors. Let's switch to purple. If I look at angle C right here and angle 1, those two angles together form a line. All right, so I have the measure of angle C plus the measure of angle 1. And we learned way back in chapter 1 or chapter 2 that all lines contain 180 degrees. Okay, so if I add those two together, I get 180 degrees. Now by our transitive property, look, we have 180 degrees here and 180 degrees here. So we can set these equal to each other. Running out of room, let's expand out a little more. Okay, so if I combine these two equations together, I get the measure of angle A plus the measure of angle B plus the measure of angle C. That equals 180 degrees, right? And 180 degrees equals the measure of angle C plus the measure of angle 1. All right, so I cross off my C's because I have a C on both sides, and I end up with my theorem. The measure of angle A plus the measure of angle B equals the measure of angle 1. So it's just a cool little theorem that lets you find an exterior angle based off of the two interior angles that it doesn't meet at. All right, so now that we've reviewed those theorems, let's actually do some problems with them. So, oops. Copy this off here. And open it up. Okay. Should make it a little bigger, huh? All right. So up at the top here, example number 3, we have use the diagram at the right to find the measure of angle DCB. I really should make this bigger. Let's see. Can I make it bigger? There we go. Blurry, but bigger. So basically, we're trying to figure out DCB, which is this angle right here. Okay. And we've been given that B is 73 degrees and A is X degrees, and we don't know what the angle C is, but we want to find what this exterior angle is. So we are going to use theorem 4.2, right? We just learned this. Theorem. Got a little, there we go. Theorem 4.2, which says that my exterior angle is equal to my two non-adjacent interior angles. Remember, the adjacent angle would be C. So we don't want that. We want the ones that are opposite, non-adjacent, basically. So I am going to say, if I want to write this out as a formula, that the measure of angle A plus the measure of angle B equals my exterior angle. So that equals the measure of DCB. All right, so now I'm just going to fill in the blanks. The measure of angle A is x degrees. Okay, we got a variable there. All right, and then the measure of angle B is 73 degrees. And then the measure of DCB is 3x minus 9 degrees. So now, once we fill this in, we have a good old algebra problem, right? So we can take off our degrees if you want. We're going to solve for x, right? Okay, so let's send this x to the other side. We'll subtract x from both sides, and we get 73 equals 2x minus 9. Then we're going to add 9 to both sides, and we get 82 equals 2x. Divide both sides by 2. This is good algebra review, right? And we get x equals 41. So we're close. We're almost there, right? We know that x equals 41, so that means that this angle right here is 41 degrees, okay? But we want to find the measure of angle DCB. And don't forget, DCB is 3x. So we got a little more work. We need to do 3 times 41 minus 9. So that is 123 minus 9, or 114 degrees. 114 degrees. So just for fun, because, you know, algebra is awesome, let's just find out what the measure of angle C is. So B is 73, A is 41. When I add them all together, so if I do angle A plus angle B, sorry for the messy writing, plus angle C, that should equal 180 degrees, right? So if I do 41 plus 73 plus C, which I don't know, that should equal 180 degrees. And I do the math, and I say, what is 180? Let's pop up the calculator here. Maybe. All right, here we go. So I have 180 degrees minus 41 minus 73. And I end up that angle C is 66 degrees, right? That's just adding up the 3 interior angles. Well, now if I look at my exterior and my interior angle, 114 plus 66 should also be 180 degrees. So let's maybe scoot the calculator over. Okay, so now I'm saying I've got my exterior angle of 114 degrees plus my interior angle of 66, and that is 180. That's how we would do that. All right, so let's try another one. I'll try to make it a little bigger this time. Pop back over here. Zoom in a little bit. We're going to actually go to 3 and then back to 2. So let's start with 2. Just to make sure you have it. So this one we're not quite explain as much, but we will we'll totally get it. Okay. Find the measure of angle 1 in the diagram shown. All right, so we know a couple things, right? We know that A is 2x, B is 52 degrees. We don't know angle 1, that's what we're trying to find. And we know the exterior angle to angle 1 is 3x plus 16. So based off of what we know so far, we have a couple of different things that we can write. All right, so let's just write all of the different equations that we know. We know that the measure of angle A plus the measure of angle B plus the measure of angle C. So all my inside interior angles equals 180 degrees. It's like your favorite new number, right? 180 degrees. All right, we know that from theorem 4.1. From theorem 4.2, well, let me leave a little space there. We'll go down a little bit here. From theorem 4.2, we know that my exterior angle, so measure of DCB, is equal to my two non-adjacent interior angles. So measure of A plus measure of B. So let's just start with those two. We also know that angle 1 plus my exterior angle equals 180 degrees as well. But I think between these two theorems, we can kind of figure it out. Oops. Don't want to erase all that. Okay. So let's fill in the blanks. We know that the measure of angle A is 2x. Okay. The measure of angle B is 52. And we don't know C, we're just going to call angle 1 equals 180 degrees. Okay, well, this is promising, except I can just solve for angle 1, but I have this 2x, so that's kind of getting in my way, kind of cramping my style, so that's not cool. So let's try this next one. I have DCB is 3x plus 16. The measure of angle A is 2x, and the measure of angle B is 52. So what I was saying up here was not cool is the fact that we have a x, which is one unknown, and we have the measure of angle 1. That's two things that we don't know. So we always want to have an equation with one thing we don't know so we can solve it. So by using theorem 4.2, we can figure out what x is, right? We know have algebra skills, we can figure that out. So we're going to solve for x. We're going to get the x's on one side together. So we get x plus 16 equals 52, and then subtract 16 from both sides and get x equals 36. All right, so that's pretty good, right? So x equals 36 degrees. We're not quite there yet, though, because we need to figure out, ultimately, we're trying to figure out what the measure of this is. Okay, so up here, I had this equation, but I unfortunately had a angle 1 that I'm trying to find, and I have an x that I'm trying to find. Well, now I found x, and I can plug it back in. So instead of writing 2x, I'm going to do 2 times 36, which is 72 plus 52 plus angle 1 equals 180 degrees. Kind of running out of room. We'll start over here, right? Now this is just a matter of my calculator, right? 72 plus 52 is 124 plus angle 1 equals 180. And angle 1 equals, dun, 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 dun. If we subtract that, we get 56 degrees. So we are going to say that the measure of angle 1 is 56 degrees. Now there's another way that you could have done this. You're like, oh, I'm good. I got one way, I'm good. The other way you could have done this is just looked at the fact that these two angles make up a line. So we also know that 3x plus 16 plus the measure of angle 1 equals 180 degrees, right? So not only did the method we used was from theorem 4.1, where we said the interior angles all add up to 180 degrees. We could also use the knowledge that my exterior plus my interior angle on a line add up to 180 degrees. So we'll end up at the same point. So this would be 3 times x, which is 36, plus 16, sorry for the weird parentheses, plus the measure of angle 1 equals 180 degrees. So if I add 3 times 36 plus 16, where's my calculator? Well, it would have been faster to just do that. So 3 times 36 plus 16 equals 124. So 124 plus the measure of angle 1 equals 180. So then I subtract 124 from both sides, and I end up with the measure of angle 1 is once again 56 degrees. So 2 ways to get to the same spot. All right, the last problem is to, let me double check your homework and see if we have one example from your last problem in your homework. So give me just a second. I'm opening up your book and checking for one to see if we need to do example number 2. It's 1 through 11 all and 14 through 26. No, so we don't need to do that example. Yep, we don't need to do that example. All right, so that's the end of 4.1. I'm going to record 4.2 separately, so make sure that you watch that. It'll be another exciting video. Thanks for watching. Bye, guys.